Okay, welcome back. This is 5.4, sum and difference formulas. This is part 2. At this point now, if you've been through the first video and done some of the homework, you should be comfortable with these formulas at this time. So let's just jump into it. We left off. I'm going to jump to number 48. I'll refer back to those so you can see them again, but I believe that we should be comfortable with those formulas. All right, in 47 through 50, find the exact value of the trigonometric function when sine of u is negative 7/25 and cosine of v is negative 4/5. Let's go ahead and draw these. This is quadrant 3 for both of these. So quadrant 3, here's angle u, produces a y on x of negative 7, or y on r, excuse me, negative 7 on 25. And here's angle v, also in quadrant 3, produces an x on r of negative 4 to 5. That makes this a 3, but it's down. And how about that? Isn't this a Pythagorean? Let's take a look. Let's clear this. If I go 25 squared minus 7 squared, and I square root that, second square root, second answer, and we get 24. I thought that was a triple. So this is 24, but it's to the left. So there's our values. Cosine of a sum, hopefully we remember this now, but cosine of a sum is cosine, cosine minus sine, sine, switch the angles. So this is cosine u cosine v minus sine u sine v cosine of v. Boy, people make mistakes on this, and at this time there should be no reason to make a mistake once we have these drawn. We got to get the negatives in there correctly, but no reason. We're going to take our time. Cosine of u, so cosine from here, negative 24 on 25 times cosine of v, negative 4 on 5, minus sine of u, negative 7 on 25, times sine of v, negative 3 on 5. Lots of negatives. That gives us 96. Notice we get common denominators. That will happen. Common denominator, 5 times 25, 5 quarters, $1.25. Minus, minus, minus. That becomes minus 7 times 3, 21. And we end up with 75 on 125. Can you believe that? Divide by 25 and I get 3/5. Okay. Cosine of a difference. Well, good news here, the fact that these problems, this cosine of a difference, but treat this like it's a new problem. Again, we just have the same information here. Cosine of a difference, do we know that rule? We should. Looks just like this one, except plus. Cosine of a difference, cosine, cosine, plus sine, sine. So this is going to just be cosine u, cosine v, plus sine u, sine v, and we dot, dot, dot. That would all end up getting us to here, but the only difference is this would be plus, making this plus. So we end up back here with 96 plus 21 on 125, or 117 on 125. All right, now for some sneaky ones. This is cosine inverse. This x is not an angle. X is a ratio that goes into an inverse trig function. Remember that? What goes into trig functions? Angles. What comes out? Ratios of side lengths. So what goes into an inverse function? Ratio of side lengths. What comes out? Angles. This is like angle theta minus angle fish. And I'm going to draw those angles right here. So I've got, here's theta. No negatives here. I'm just going to put it in the first quadrant. The cosine ratio is x to 1. The cosine ratio is x to 1. In angle fish, the sine ratio is x to 1. Now, Pythagorean, if I think of this as, well, this is going to be easy for you to follow. This squared equals this squared plus this squared, so this guy over here squared equals this squared minus this squared. That's 1 squared minus x squared, but the square root of, so that is square root of 1 minus x squared. Likewise, 1 squared minus x squared, square root of, this is square root of 1 minus x squared. So now cosine of my theta, see that's arc cosine x right here. Arc cosine, or arc sine x is right here. It's this angle. There's fish, there's theta. So theta minus fish, cosine of a difference. What is it? It's cosine cosine plus sine sine. So I need cosine theta, cosine fish plus sine theta, sine fish. Okay, we're going to take our time on this. Cosine of theta, x on 1, times cosine of fish, square root 1 minus x squared on 1, plus sine theta, square root of 1 minus x squared on 1, times, this should be sine fish here. Sine fish, I'll bet you saw that, x on 1. And if you notice everything's on 1s, that's good news. And here I've got an x times this thing and an x times this thing. I have two of these things. 2x times square root 1 minus x squared. Okay? So we're going to treat this one like, let's go, here's a new theta and a new fish. I'm going to draw those. This one's similar to what we just had. Here's angle theta, creates a sine ratio of x on 1, and fish creates a tangent ratio of 2x on 1, tangent y on x, opposite adjacent. Pythagorean, just like what we saw before, 1 minus x squared's root. How about this one? Here it's going to be 1 squared plus 2x, careful, 2x, all of it squared, square root of that. So it's big square root of 1 plus 4x squared. Okay? So I need cosine of theta minus fish here, which is cosine plus sine, and we got it if we're careful. See, angle theta right here. There's angle theta. Our cosine ratio is square root of 1 minus x squared on 1. Cosine of fish is 1 on square root of 1 plus 4x squared, plus sine of theta, that's an easy one, x on 1, times sine of fish, 2x, on square root of 1 plus 4x squared. See, common denominators, they happen. Numerator has a term of 1 minus x squared in it and a term of plus 2x squared. And I'm just going to let you know, the back of the book, I don't believe even rationalizes this. You could. You're going to get a bigger mess. They might put the 2x squared first. That might be the only thing that they do differently. Okay. Along the same lines. This is an angle. In fact, in some ways, this one's easier. This is an angle cosine, it's hard to see, but this is cosine inverse. Cosine inverse of -1. Well, that says when is cosine -1 close to 0? Let's see. Cosine, the graph of cosine looks like this. And it's -1 here and here. Either pi to the right or pi to the left. Which one should I choose? We go close to 0. There, it's a tie, so we go positive. So this is sine of, see, this is a known value. Pi plus pi, that's sine of 2 pi, which of course is equal to sine of 0. And the graph of sine, here's cosine, the graph of sine looks like this. Sine of 0, that's not theta, is it? It's just sine of 0. Sine of 0 is 0. Okay. This asks, when is sine 1 and close to 0? So here's sine. When is sine 1 and close to 0? Right there. And of course that's pi on 2. This asks, when is cosine 0 and close to 0? Right there or there. At pi on 2. But we choose the positive when it's a tie. So this is asking for what's cosine of pi on 2 plus pi on 2 pi. Well, cosine of pi, if I continue this, there's pi. Cosine of pi is -1. Oh, there was, once again, I cut off my zoomed in feature. So this is asking, I'm just going to go through that again real quickly. When is cosine 0 close to 0? Well, cosine 0 close to 0 here and here. So we choose that positive one over there, which is pi on 2. All right, not so bad. This, in some ways, even easier. Use right triangles to evaluate the expression. Cosine inverse. See, this thing's an angle. I'm going to call it theta. I'm going to call that one fish. I'm going to build theta. It's positive. It's in the first quadrant. It is x on r 3 to 5, making this 4. Pythagorean triple. It's a family. Here's fish. I'm going to build it first quadrant. It's y on r 5 to 13, making this 12, Pythagorean triple. So cosine of theta minus fish, sine of, that's good that we switched to sine. Sine of theta minus fish, we should know what that one is by now. Sine of a difference is sine cosine minus sine cosine, switch the angles. So it's sine of theta cosine fish minus sine of fish cosine theta. And if you're watching me and doing these along, no big problem in this. If you're successful on the test, great. But it'll be pretty clear to me who crammed at the end, because I know the book's going to do this differently than I did. Not that my way's better by any stretch, but I just always go sine cosine, sine cosine. Switch the angles. All right, so sine of theta is 4 on 5 times cosine from fish, 12 on 13, minus sine of fish, 5 on 13, times cosine theta, 3 on 5. Now it's worth taking a moment just making sure all of those are different entries. But anyway, we do get that least common denominator, 65, and I get 48 minus 15, or 33 on 65, which sounds like a familiar one maybe from yesterday's work. Okay, verify the identity. Interesting. I guess we'll work on this side, and all I can do with this is treat this as a difference. Sine of a difference is sine cosine minus sine cosine, switch the angles. It's supposed to equal sine of x. And I'll have people get stuck on this identity problem. Well, what in the world do I do there? Well, this and this are known values. 3 pi is 1, 2, 3. It's right, it gets us to right here. And right here, these values could be -1 and 0, and r is 1. And sine is y on r. That's 0 on 1. This is 0 times cosine of x minus sine of x. Cosine is x on r, -1 on 1. And I get 0. Minus times minus plus, I just get sine of x equals sine of x. There you have it. Trig identities. What can I do? Tangent of a difference. Do we remember tangent of a difference? Tangent of a difference is difference of the tangents all on 1 plus the product of the tangents. And I look at what I'd like to have. I wish tangent of pi on 4 was 1 and the top would be right. And if tangent of pi on 4 was 1, the bottom would be right. Well, tangent of pi on 4 is 1. Okay. And here. Need some room here. Cosine of a sum is cosine cosine, cosine x, cosine y minus sine x, sine y. So there's that one. Plus cosine of a difference is cosine x, cosine y plus sine x, sine y. And let's see, I got a cosine x, cosine y, and another cosine x, cosine y. I've got two of those apples. I got a minus sine x, sine y, but I've got a plus sine x, sine y. So those cancel. And all I got to do is be able to convince the reader that this equals this, and I think we can do that. Okay, so there is 5-4, the rest of the assignment. This was the part 2 video. If you haven't seen the part 1, you need to have those notes done, and that should be helpful in explaining things. Again, I mentioned this, but I'm going to mention it again. It's worth noting. At this point, when you are through with this assignment, I can't imagine how you could finish this successfully and not have these guys committed to memory. So those will not be given to you on quiz test, because if you're doing the work, you naturally will have those things memorized. All right, good luck. Let me know what I can help you with.